This video is for invented strategies of multiplication, that is of multi-digit whole numbers. So the first invented strategy that I'm going to use is a visual way to show multiplication. And it also works with breaking them down into their extended notation. So extended notation, 300 plus 20 plus 6 times, and I'm going to put these in parentheses, 200 plus 20 plus 9. That is their extended notation. I just broke them down into their place value units. So this is 6, this is 20, this is 300. Okay, so when I start teaching multiplication, I always love to show the relationship with a square. I also love those little pegboards. It's basically a piece of wood or plastic, and it has little pegs in it, and you could take the rubber band and wrap it around it. Obviously, you're not going to use it for teaching them multi-digit multiplication because this would be an insanely huge board. But when you're first beginning, it's a good way to introduce the idea of area, as well as let them count each little unit to see what the answer is. So I'm going to start off with a rectangle, sorry. That wasn't drawn to scale at all. I'm going to try to do one a little bit better. Okay, so I'm going to take it into its extended form. So we know that this is 326 and 229. And the answer is going to be the area of this rectangle. But instead of going ahead and doing it that way, because that doesn't help me at all, I'm going to break it down. This piece of the rectangle is going to be 300. This piece of the rectangle is going to be 20. And this piece of the rectangle is going to be 6. Now I need to do this side. So I'm going to say this piece is going to be 200. And this isn't drawn to scale at all, but it serves its purpose. This piece is going to be 20 and this piece is going to be 9. So now I want to find the area or the measure of each of these rectangles. So this one is 200 by 300. So this one we know is going to be 60,000 because 2 times 3 is 6, and then we count the zeros for 4 zeros or 60,000. Now 2 times 3 gives us 6,000, or 20 times 300, sorry, is 6,000. 9 times 300, that's going to give us 2,700. Now 200 times 20 is 4,000. 20 times 20 is 400. 9 times 20 is 180. Now we're going to go 200 times 6. I made this box kind of small, but it'll work out. It's 1,200. 6 times 20 is 120. And 6 times 9 gives us 54. Okay. So, now that we have this, we're going to add up everything inside of here. So that looks like a lot, but the great thing about this way of multiplying is all of these are smaller numbers and most of them are zeros. So it's going to be easier numbers to work with. So I'm going to start here. 60,000, 6,000, and 2,700, 4,000. And you could break them up and do them, but I'm going to just do them all at once. Alright, so like I said, these are easier numbers to work with. I have all zeros and a 4. I have an 8, 10, and a 15. So now I have 7, 10, 14, 15, 16. Make sure you line them up or else this won't work. So we have 10 and 14. And 7. So my answer is 74,654. So this is how I think it would be great to teach multiplication. This is just one way of showing it, because each of these little pieces, once you add them together, is going to make up the whole. It's kind of the same idea as a tape diagram. It's showing each little piece added together is going to make up the entire thing. So why does this work? I'm going to relate it back to standard algorithm. So in standard algorithm, we did 9 times 6. That gave us 54. We did that here, 9 times 6. So this one's done. Then we did 9 times 2. That gives us 18. Or 9 times 20, because we learned that in the last video. This is 20, not 2. So that gives us 18, 19, 20, 21, 22, 23. So we did 9 times 20. There's a 9 times 20 right there. We got 180. We just didn't have to carry anything in this one because it was done here in this step. Alright, so now we have 9 times 3. That gives us 27, 28, 29. So we got 29. This is actually 9 times 300, so I'm going to go find my 9 times 300. It was right here. Now we got 2900 in this one, but that's because we didn't have to carry anything. Again, that's in this step here. So now I'm going to move on to my tens place, and remember to put a 0 here because it's not a placeholder, but it's, you know, place value. You need a 0 because we're multiplying in the tens place now. 2 times 6, or 20 times 6, 20 times 6 gives us 120. So we get 12. We don't have anything to carry because that's from the last one. So we're going to do that. 2 times 2, or 20 times 20 gives us 400. So we get 4, 5. Now we have 20 times 300. So 2 times 3 gives us 6. So here we are. We've used all of these up. We're going to move to the next one. Different color. Going to the hundreds place. 2 times 6 gives us 12. 2 placeholders, 12. 2 times 2 is 4. 5. 2 times 3 is 6. Alright. So we used the 2 times the 6, or the 200 times the 6. We used the 200 times the 20. And we used the 200 times the 300 right there. Let's see if we get the same answer. So I got 4, 5. This is 11, 16, 6, 7. Alright. So we got the same answer, and this is why. Each of these steps we actually did here. This was just a more visual way of showing it. So you're still multiplying each number by each other. You're just showing that this is 200, not 2 times 3. This is 200 times 300. So I think it's a more conceptual way to teach multiplication than standard algorithm. Standard algorithm may be a quick way, and it might be a more procedural way of teaching it, but I don't think they're really going to understand the concept with this as much as they would with this. So another strategy that I want to talk about is lattice. So I went over lattice with addition as well. I don't really like lattice as a teaching strategy. I just think it's really fun because it looks, it looks crazy and it freaks people out. So with lattice, I'm going to use another box. We know I like boxes. So I have 326 and 229. So I gave each number this time their own box. It's similar to what I just did with the 200, 300, 26, 20, and 9. It's similar, but it's not the same. We gave each one their own box. So now what you're going to do, you're going to put lines and divide each square diagonally. So now we have triangles. So now all you do, you say 9 times 6, that's 54. This, again, just like the one with addition, this bottom triangle is always going to be the ones place. The top triangle is, oops, not even a triangle. Top triangle is always going to be the 10th place. You're not going to need a hundreds place or any of those because one digit number times a one digit number should always be a two digit number. Okay, so we got 54. We're going to move on. You can do it in any order you want. You do not have to go in order. So now I'm going to do 2 times 3. That gives me 6. There's no 10s in 6. There's just 6 ones. Move on. 2 times 2. That gives me 4. Just make sure you put them in the right square. So 2 times 3. That's 6 again. 9 times 3. We know that's 27. 2 10s. 7 ones. 2 times 2. 4. 9 times 2. 1 10, 8 ones, or 18. Now we have 2 times 6, that's 12, and I'm just going all over the place. You can go in any order you want with lattice, which is really cool. Okay, now we have this crazy set of numbers, and this is what looks so scary. I love seeing parents freak out about this one on Facebook. It does look scary, I agree, but this is almost exactly like what I showed just a second ago. So to get the answer, you're going to drop this down. This is 4. You're going to add going this way. So we have 8, 10, 15. So now we have 7, 10, 11, 12, 13, 14, 15. Why did I put a 1 there? I don't know. I was supposed to carry that. 15, 16. 10, 11, 12, 13, 14. And this is 7. So we have the same answer that we got earlier in almost the exact same way. So you remember how this was 200, this was 300, 20, 20, and 9. We did 200 times 300, and we got 60,000. You're basically doing the exact same thing. 2 times 3, you're still multiplying each number by each other. You're just adding down the rows this way so that you have, less complicated numbers to work with. When you carry, you still carry, and you can put it in, up here, you can put it down here. It's whatever. But you still get the same answer, and it's almost the exact same thing as the other way. You just don't have to rely so heavily on place value as the other way. Okay.